Welcome to Altair Engineering Training and Support. In this tutorial, I am going to show you how to create 2D meshing on the roll cage structure. So we'll start with open the hypermesh, go to all programs, Altair HyperWorks 12, hypermesh. This will open the GUI. Select the number of days left and select the radius bulk data and say OK. Then import the model, the roll cage structure in hypermesh. To import the model in roll cage structure, click on import icon, select import geometry, select the file type of the CAD model which you have for the roll cage structure. As I have a IGS file, so I will select IGS as a file type. Then click on folder option, browse the location and select the roll cage IGS file. Enter the scale factor. If you have created your roll cage structure in any of the CAD software using inches as the distance panel, so enter the scale factor as to 25.4. Otherwise, if you have the if you selected for the roll cage CAD model, enter the scale factor as 1 and click import. This will import the CAD geometry, as you can see here. Then close the import option. In the model browser, you can see one component is created which contains the CAD geometry of your roll cage structure. To view the surfaces of the CAD geometry, click on the shaded geometry and surface edge option. This will show you the surfaces. And also to view the edge representing colors, select mixed. I will explain you first what are these colors of edges represent. So if you click on visualization, you will find there are different edges with the different colors. That is, first one is free edge. This edge shows that this edge shares only one surface. Shared edges represents this color edge shares two surfaces. Suppressed edge means these edges are suppressed and it shows that it is a continuous surface, but later on if you want to bring it back or split the surfaces using if you want to split the surfaces, you can use the suppressed edges. And non-manifold edge means on that particular edge it is passing 3 or more surfaces. So non-manifold edge shows you that 3 or more surfaces are passing from that particular edge. So to create a 2D mesh on the roll cage structure, first I need to create a mid surface on the roll cage structure, because in the 2D meshing I provide thickness on the property, so it will assign the thickness of the elements. And for the hollow structure, if I provide the thickness, if I mask it, I will explain you better. Click on the mask icon, this, and mask, and then click on reverse. So here you can find it like this is the hollow pipe. So to simulate this, you have to create a mid surface on this particular pipe section, so that once you assign the thickness, it will capture the complete geometry of this roll cage structure. That is the thickness of this roll cage structure or the circular pipe. Because if you create the meshing on the outer one, so it will assign the thickness on the outer one and the geometry of your roll cage structure will not be simulated properly. So to simulate the actual roll cage structure using 2D mesh, you have to create a mid surface and do the meshing on that particular mid surface. So to create the mid surface, I'll again click on unmask all. So during the import of the IGS file, sometime it may create some solid geometries that I will show you. So click on surfaces, all and mask. So these here it creates some of the solid geometries. So if you pick here as solids and select this, you will find that this is a solid geometry. If you make it in a line mode, you can find it like this. This is the complete solid geometry. That is, it is not hollow as per the thickness. So we cannot create the mid surface of this solid geometry. So we will delete this solid geometry. So to delete the solid geometry, go to delete panel. Click on the drop box. Go to right and click on the right extension and select solids. Click on the solids, say all, and click on delete entity. So it will delete all the existing solids on your roll cage structure. Then click return to exit the delete panel. Again click on surface, shared edges, shared geometry and surface edges to view the geometries. Now to generate the mid surface of the roll cage structure, click on geometry page. In geometry page, select mid surface. So to create the mid surface of the roll cage structure, click on geometry page, mid surface. In geometry page mid surface, select auto mid surface. Make sure you have selected the incomplete solids. Option is on. Select the surfaces and click on all. So it will select all the surfaces. So you can see all the surfaces it has picked. And say extract. So once you click extract, it will extract the geometry. So in this way you can see it has generated the mid surface. So click on exit or return to exit the mid surface panel. If you off the main geometry, you can see some of the surfaces it has missed out, like this one. If you again on it, so like this one, the top one, it has missed out. So you can create the manually the surfaces which it has missed out, the mid surfaces you can create manually also. So we'll go one by one. First mask these surfaces, say reverse, return and return. So we'll create the mid surface manually. For those surfaces it didn't create the mid surface automatically, we can create it manually. So to create manual mid surface, go to geometry, mid surface, select surface pair option, select the first surface and the second surface and click on extract. So it will create a mid surface. Again click on first and second and say extract. So in this way it creates a mid surface for this structure. Or if you make this in a transparent mode, so you can able to find out which are the reasons for which it has missed out to find the mid surface. You can also change the color of the mid surface to check the areas where it has missed out. So these are the areas where it has missed out. So again you can, to generate the mid surface, you can just go to mask panel first, mask the surfaces, reverse, and then select the two surfaces, first, second, mask, first and second surface and say extract. So in this way it will create a mid surface, as you can see. Again go to mask panel and say unmask all. Then for this structure it has missed out, so I will select two surfaces at a time, first this one and this one. For this it has missed out, say mask and reverse. So I will create the mid surface for these two structures, say return geometry page mid surface, pick this one and the second one and say extract. If you press the scroll button it will done the highlighted option, this one and this, so highlighted is extract. If you click on the scroll mouse button, so it will do the highlighted option. Similarly for this structure, first this, second, and first this and second, so it has created the mid surface again. So if you on off these two surfaces you can find out like, so if you again off this you can find that none of the surfaces are missing, but there are some red and yellow edges are there. So if you again go to visualization panel, click on visualization and off the shared and suppressed edges, make it into line mode, so you will find it like these are the areas where it has created the duplicate surfaces. So the areas where it create the duplicate surfaces, we have to remove them, otherwise during the mesh it will create the duplicate elements on that particular mid surface sections. So I'll again move it to the shaded geometry on all these options. So one by one I will select and delete the duplicate surfaces. So I will select this one and this one, so it converted into green, as you can see. Then this one, it has converted into green, this one, then this one and the bottom one, it has converted into green, the top one and the bottom one. Similarly the top one and the bottom one, again the top one and the bottom one, the top one. So in this way you have to select one surfaces and make all the edges as green. So you have to select one, then the other. So all these are duplicate surfaces. So along the thickness, along the length of the pipe, we have to edit the geometry. Along the joints, we will edit it manually. So if there are red, green, yellow edges are there along the joints, so we will not remove them initially. Then this surface and this one. Similarly this one and this one, this one and this one. Now I will again cross check it, go to line mode, that is wireframe geometry, and again off this shaded geometry and suppressed edge. So now you can see these are the red color edges at the joints, so no red color or yellow color edges along the length of the beam sections or the tube circular pipes. So now I can start the geometry editing for the 2D meshing. I'll again on these two shared edges, then click return. So as I can see, my roll cage structure is symmetric along the YZ plane. So I will cut it down to the center axis and work only on the first one half of this portion, and then I can reflect it so that I can save my time. So in Hypermesh you have the option to reflect it. So I'll show you how to cut down this roll cage structure into a circular or center portion. So to split it to a circular portion, you can go to geometry. In geometry page, select surface edit. In surface edit, select trim with surfaces. In trim with surface option, select with plane the surfaces and select all the center surfaces. Select only all the center surfaces. Select the x-axis which is perpendicular to the plane, that is, this is YZ plane, so x-axis is the perpendicular. So from drop box select x-axis and select the center base point and click on trim. So it will trim all the surfaces using this center base point. Then go to delete panel. Once this, up till this portion, keep on saving the file, otherwise if anything went wrong, so you have to do this all these steps again. So always keep on saving this file. So I'll create one more folder and save this file as roll cage mid surface and click on save. So this is the mid surface of my roll cage structure. Now I will delete this other half of the any one half of the portion of the my geometry. So I am deleting this half of this geometry. I can delete the second half also. So now I will only work for these joints and do the meshing along this side, and then I will reflect the elements, the mesh model of the half roll cage structure to the other side, so it will get completed and the symmetry should be maintained. So to maintain the symmetry, you can use these types of options available in Hypermesh. So I will move to one by one to see all the joints are connected or not. So you can see here these joints are not connected. So I will show you how to connect these joints one by one. Also I will now save this again as the mid surface half portion. So in this way I have saved this file again. Now I will connect all these joints. So click on mask and save. So only this portion of the entire geometry you can view on the GUI. So there is a perfect flow of options available in Hypermesh which you can use to edit the geometry or to join all the joints of your roll cage structure. So first you have to split into a circular portion. So press F11 from your keyboard to enter to quick edit panel. In this, select split surface lines, make it into wireframe geometry. From this node to this node, again to this node, make that into a wireframe 1. Select this node to this line, so it will split this. Similarly, you can press escape. Make sure this line option is toggled to lines, so that once you pick the lines, all the lines should get splitted. You have to split all the pipes. So this line to this line. again from this end to this end, again to this end. So in this way I have splitted down all the 4 pipes which is forming a joint in the roll cage structure. Then delete these sections, these cutout sections which I have splitted out, and then we will use extend commands to extend these pipe and create a proper joint. So to enter to extend commands, press Shift F9 on your keyboard. To enter the extend command and or surface edit panel, go to press Shift F9 from your keyboard. In this, select extend command. Make sure you have selected extend over edge option. From the drop box, select by distance. Enter an arbitrary distance of 100 and select the line which you want to extend. So I will select 1 by 1 joints and extend them. So first this and this one. It should always have the cross connection, and I'll then edit these. So sometimes during the extension it may create some surfaces like this which is not properly connected. So I have to first connect these edges because they are red, so they has to be green. So again, if you want to connect these, press F11 from your keyboard and select the toggle edge option. To connect the green edges, to suppress it or to join these green edges, click on toggle edge option. Enter the tolerance value as 0.1. Tolerance stands for the gap between 2 edges. Select this and say yes. Just click on left click on the line and say yes. So it will connect these 2 edges. Click return. Again click return. Then again go to Shift F9. Trim with surfaces. Click on first surface with surface option. To trim this 2 surfaces, go to trim with surface plane, select with surface, select any one surface and click on the second one and click the second surface. Make sure the trim both option is on and then click on trim. So it will trim both the surfaces. Then go to delete panel and delete the extended surface which is generated after the trim. So as you can see, once I am selecting it, it's selecting the whole surface, the complete surface it is selecting. So now I will edit this by creating the lines. So I will go to mask panel and mask these 2 complete surfaces and say reverse. So these are the areas where, that's why it's creating the complete surfaces. So I will create a split line on this area. So to create a split line, press F11 from your keyboard, select split surface line, select this node to this node. It will create a split line. Again from this node to this node, it will create a split surface line. So if again you go to the delete panel, you can delete these 2 surfaces. Then again click on unmask all. Then click on mask and mask all these surfaces and click on reverse. So now you can only view these surfaces. After editing these surfaces, you have to edit these 2 surfaces also as per the lines which I have created. So again press Shift F9. This time select trim with lines, select surfaces, then select the lines and just click on trim. So it will trim the surfaces. Again select the surface. As you can see, it is selecting the through surface, but I want to retain this surface. So click on surface, lines and trim. Then go to mask panel, select all the outer surfaces and click on mask and delete the inner one. So I have deleted this one. So sometimes it will have these red edges, so you can just toggle it down. Go to F11 and toggle these surfaces. Also you can remove these unwanted splitting surfaces by unsplit option, so it will get removed. And also you can remove these points. By creating node to node option and by add removing. Similarly from this node to this node. Or from this node to this node, and toggle this and click on add remove point to remove this surface. Then I will extend this surface and connect it properly. So press shift F9 to enter to extend command. Keep all the other parameters as it is. Select the edges on which you want to extend this. Select trim with planes. Select this surface. Select these two surfaces with which you want to trim this. You have to make sure that the trimming surfaces are selected properly. And click on trim. Now again go to delete panel and delete the extra surfaces, the extended surfaces. Then again go to mask. Mask all the outer regions, outer surfaces of this joint. Say mask and just delete the inner bound. Again click on mask, unmask all. This icon is used for unmask all. Then press F11 from your keyboard and unsplit the unwanted lines on your geometry. This option will remove all the unwanted lines on your geometry. Always keep on removing the unwanted lines on your geometry so that while doing the meshing it will create a good mesh. Again press shift F9, extend, select extend over edge and click on extend. Then trim with planes. This surface I have to trim with these two surfaces because only for these two surfaces it is intersecting, and say trim. Go to delete panel, as it is not splitting properly, so I will again select these two surfaces and ask them to trim with these two also. Then go to delete panel and mask these two surfaces. And I have to check why it is selecting the complete geometry. So as you can see there is a small gap here, so I have to fill this gap. So to fill this gap or to split this surface along this, go to F11, split surface line, pick this node to this line, then this node to this line. Now once you select these two surfaces to delete, it will delete these surfaces. Then once you click on unmask all, you can see it has deleted these two surfaces. Now as we have splitted along this edge, so I have to trim it along also. So shift F9, trim with lines, pick this surface, select the line and say trim. Then mask all the other surfaces, that is all the outer surfaces. just rotate this model to see whether any of the surfaces are left or not, and delete. So in this way, and then again press F11, unsplit, and just unsplit all the unnecessary splitting lines which is generated due to the trimming of the two surfaces. Here you can see there is a small gap, so we can remove it. Also, instead of having these two nodes at very closer end, you can join these two nodes using replace point. Similarly, here also you can join these two nodes using replace point. So now if I click on wireframe geometry, you can see this is the complete hollow joint. So once I create a 2D meshing, it will have the completely joint structured meshing. So in hypermesh, either you have to connect the mesh or you can connect geometry and then do the meshing on the connected geometry. So in the initial stage, in the first learning stage, it's always better to connect the geometry and do the meshing. Then click on return, click on shaded geometry. So this first joint has got completed. Now I will save this file, half portion, rename it to 1. Then I will move to the next joint. I will mask this and say reverse. Then again I will first is to make it into line mode. Press F11 from your keyboard. Select split surface line. Instead of line, toggle it down to lines. From this line to this line, create a circular cross section so that it will extend properly. Again, make it to shaded geometry. Delete these two surfaces. Press Shift F9 from your keyboard. Go to extend command. Select these two edges. Say extend. Then select trim with surface plane. Select first surface. Click on the second and select the second. And click on trim. If it doesn't create the surface split, you have to just split it manually. Similarly on this side also. And Shift F9, then trim with lines. So you have to select these surfaces for the trimming. Similarly, this surface and this line for the trim. Then you can see, you can delete it. And just you have to mask all the outer surfaces. Mask and delete the inner left surfaces. We have to check the trimmed surface whether it is connected properly or not. So you can see here there is a small gap in between these two edges, and just unsplit the unwanted surfaces. Also we can replace these points. So in this way I have edited one more joint. Now I will save this file again. After editing every joint, you just save it so that if anything went wrong, you can have a later joint completely done. Now I'll go to mask and reverse. So for this structure you can see these two pipes are properly joined, only the first one is not properly joined. So I will go to F11, taking in the line mode, and create a split line here. Again convert that into shaded geometry. Go to delete panel and delete this line. As you can see, there are some extra surfaces on this, so I will mask all these surfaces and delete the extra surfaces. if this type of surfaces are removed from your geometry by mistake, you can create it by manually. Go to F11, filler surface. So once you click on filler surface, it will fill the entire surface. Or go to 2D, spline, select the lines and say surface only. Make this as current component and say create. So it will create a surface using these lines. So now I will unsplit this line, or you can toggle it. Also you can use unsplit here. So always try to remove unnecessary edges so the meshing will be better. Then press Shift F9, go to extend panel, select these two edges and extend them. Go to surface, trim with surfaces, select with surface first and then these two surfaces and say trim. Then go to delete and check whether it is properly trimmed or not. So it has a small gap here. So again go to F11, select node to line. So it has splitted here. Similarly, you have to split from this line to this point to this point. So it has split here also. And then again go to Shift F9, pick this surface, pick this line and say trim. Similarly, pick these two surfaces, pick this line and say trim. So now you can remove the unwanted extended surface. Then go to mask panel, select all the outer surfaces, mask and delete the inner blockage. So in this way it has connected this one, and then you can toggle the red edges. Whenever you split the surface, it will create the red edges. You have to toggle it down and then split all the unwanted lines. So it will not affect my mesh quality. And the nodes which are very close to each other, you can directly remove those nodes or replace these nodes from the closest one. So in this way I have removed some of the nodes. So now this portion has got completed. So the 3 joints has got completed. So once I will complete my one joint, I will save this file. Again move into shaded geometry. So in this way you have to edit all the joints in the similar way. I'll show you one more here, how to edit this geometry. Mask and reverse. Make it in the line mode. Go to F11, nodes to line, again to line, then nodes to line, again to this line. Make it in the shaded geometry. There is a duplicate surface is there, so I'll delete one and delete these extended surfaces. Then we'll go to Shift F9, extend these two surfaces and select trim with surface planes. So select this surface, I have to trim with this and this one. Say trim. Also we'll have to trim these also. Say trim. Now go to delete panel. As we can see, it is not selecting only this one because of the gap here. So I have to fill this gap using this node through this node, or you can go to mask and say reverse. So you have to fill this gap from this node to this node. It should create a line. Or go to trim with lines and select these lines and say trim. So it will trim all these lines. So in this way it edited the geometry, as you can see here. This surface with this line, trim, and you can just delete this surface. So in this way it has trimmed these surfaces. Again, if this type of geometry loss you find, so go to F11, filler surface, or you can go to 2D, spline, pick these two surfaces and say create. Or you can also go to line, skin option. There are different options available to create the meshing, to create the surfaces. So it has created the surfaces, just there is a small gap, so we have to fill this gap. So in this way you can see the gap has been filled out. Similarly, now again we have to mask this, all the outer surfaces. Say mask and delete all the inner surfaces, and again click on unmask all. Then we have to unsplit these unwanted lines, and then again shift F9, extend from this edge to this edge, extend, trim with surface planes, select this option. We have to trim this with these edges, and say trim. So it will trim this completely, and now you can delete the extended panel. So the similar thing you have to perform for the complete roll cage structure. So now you can see I have a completely edited geometry of the roll cage structure, in which I have connected all the joints. You can see from here. To check whether all the joints are connected properly or not, go to visualization, off these greens, make it into line geometry, and along the, if you on this, so this is the splitting plane of my roll cage structure. So only along the splitting plane the red color line should show, otherwise there should not be any red color edges or red color lines. So as you can see, along the splitting plane only my red edges are I can able to view. Rest all are green. So all the joints are completely filled, you can see here. In this way you can do the geometry editing for the complete roll cage structure. So once your mesh geometry editing is done, so these are the some options for the geometry editing for the roll cage structure. I will quickly review that. First is F11. In F11 you will require to node to lines to create the splitting lines, then node to node, unsplit to remove unnecessary splitting edges lines, then toggle edge to suppress the edges. Also you can use filler edges if some of the small surfaces are missing. Replace point to replace some close points from one point to another. Then for the shift F9 you will use extend to extend the splitted surfaces to some extension, and then trim surface with planes to trim surface to surfaces, and trim with lines to pick surface with the lines. Make sure normal to surface toggle is on. So these are the options, plus mask to mask the surfaces, and delete surfaces to delete the unnecessary surface options. So these are the 4 options you will require to use to edit the geometry of the roll cage structure. Now I will show you how to create 2D meshing on this roll cage structure. So to create 2D meshing on the roll cage structure, go to 2D page. On 2D page you will find auto mesh panel. Select all the surfaces. As you can see, I only have the one half, so select all the surfaces on the meshing. Enter the element size as 5 and mesh type as mixed. Select the second order, so it will create the second order quad or tetra element, and click on mesh. So once you click on mesh, it will start creating the elements, and say return. Again click on return. So now you can see it automatically creates the completely meshed model of the roll cage, half roll cage structure. You can see here it has created a complete mesh model of this roll cage structure. Now firstly I will go to the quality checks. It has missed some of the surfaces, as you can see. To find out the unmeshed surfaces on the surface, again go to 2D auto mesh, click on unmeshed. So once you click on unmeshed, you will find these surfaces, you will find only the highlighted surfaces which are unmeshed. Then click on mesh again. And say return. So you can see it has created the meshing. Or if there is any errors due to the on the mesh generation, you can split this from this node to this node, or from this F11, if you can split it. Yeah, you can split from this end to this end, and then again check the auto mesh panel. So it will generate the meshing. So now if you click on unmeshed, so there is no unmeshed surfaces. All the surfaces are meshed properly on my roll cage structure. So if I off the geometry, you can see this is the complete mesh model. Now before reflecting it, I will make sure it passes all the quality checks, that is warpage. Warpage stands for out of plane angle. Aspect ratio is the ratio of minimum length to the maximum length of the element. And Jacobian is the deformation from global coordinate system to local, that is the deformation of shape from the actual shape of the element from the actual shape. It should pass all the three quality checks. So to enter to quality check panels or element check panels, go to tools, select element check, select 2D in the element check panel, click on warpage. So it will show you around 67 is the maximum warpage angle is coming as. So once you click on warpage, it will show you 2358 elements are failing. So click on save failed, then go to mask, select from the drop box elements, click on the elements, say retrieve. So it will retrieve all the elements which is saved. Then click on again the elements and say reverse and mask. So it will highlight all these elements which are failing on the warpage. Then press Shift F5 from your keyboard to enter to find attach panel. Make sure you selected the radio button as find attach. Select from the drop box elements, attach to elements. Select all the elements which is highlighted on your GUI and click on find. Then again go to 2D auto mesh. This time instead of surface, select the drop box and select elements. From mesh type mix to select mesh type R trias. And select all the elements again and say mesh. So it will mesh all the elements using tria elements. Then click on return, again click on return and say click on unmesh all. Then again go to tools, check elements, click on warpage. So you can see 0 elements are failing in the warpage. Then select aspect ratio. No elements are failing in the aspect ratio. And check Jacobian. So enter the Jacobian value as 0.4. So 3 elements are failing in the Jacobian. Then to improve the Jacobian value of these, click on save field, mask, elements, retrieve, elements, reverse and mask. Then press Shift F5 and drag the window. So 3 elements will be selected and click on find. Then go to 2D, auto mesh, drag the window again, element size 5, mesh type trias and say mesh. So it will mesh these elements, say return. Again click on mask, unmask all, tools, check elements, Jacobian. So you can see still the Jacobian has increased somewhat to 0.15 but not very high. So I will again click on Jacobian, save field, mask, elements, retrieve, reverse and mask. Then I will create some nodes. So to create the nodes on the elements, go to press Shift F2 on your keyboard, drag the window and say add. So it will create the nodes. So these are the elements which are failing. So you can also manually select, just go to Shift F5 and find attach these elements. So these are the attach elements. Which are failing in Jacobian. So Jacobian means actually the shape of the element is very distorted as compared to the original one. So this is, we can make it to actual shape, very close to the actual shape. So this is the actual triangular, it is a very better. So it may pass. Similarly for this one, there are 3 elements failing here. So if you change the node's length from this to 3, so the distortion value has lowered down. Also you can change it to 2.5. Now again, if I go to tools and Jacobian, you can see 0 elements are failing. So if I click unmask all, if I click on unmask all and Jacobian, so you can see 0 elements are failing in the Jacobian. So again I will go to Shift F2 and clear all the nodes which I have created. So in this way my elements are passing to qualities, element qualities. Now I will reflect these elements to complete my roll cage structure. So to reflect these elements, I will go to tools. On tools page, click on reflect. Select from the drop box elements. Select all the elements. Click on elements duplicate. Current component. Select the base axis along which I want to reflect. So x-axis is the axis along which I want to reflect. Select any node as the base through which it will reflect and click on reflect. So once you click on reflect, you can see it will reflect all the elements. Now once you reflect it, click return. Then after reflecting, there will not be any connectivity on this area. All the elements along this side, there will not be any connectivity. So we have to check whether this is a complete closed volume or not. So because if it's not a completely closed volume, it will not behave properly. So it has to be completely closed volume. So for that, press Shift F3 from your keyboard. For that, press Shift plus F3 from your keyboard or go to Tools, Edges to find the connectivity issues of your meshing. From the drop box, select elements. Select all the elements by press Shift and left mouse button. Click on tolerance value and enter tolerance value as 0.1 and click on preview equivalence. So you will see it has picked all the nodes along the splitting edge that they are not connected, as you can see. Click on equivalence and say find edges. So once you click on find edges, you will see on the bottom of the screen that no edges were found. Selected elements may enclose a volume. So our aim for the 2D meshing to end the 2D meshing, it should have a good quality and it should not it should have also an enclosed volume. So I'll also run this model for the quality check. So I will save this file again as the mesh model and say save. Then I'll go to analysis, radius, and for this time in the run option I will say check. So it will only check whether it can run or not. So click on radius, but I have to define the load step first. So first I will create the material. As I am not going to perform any analysis, I am just checking whether these elements is having a good quality and connectivity to perform any analysis or not. I am only going to check that. So I will create a material, arbitrary material as steel, define all the properties, define the properties as roll cage, select the type as 2D, card image as P shell, define the material, click on create edit, enter the thickness as 3 mm, then go to component and update the component with proper property and material. say update. Then define the load collector as EIGRL to find out the model, some of the modes. My aim is not to find this model, and my aim is to check the elements quality, whether these type of element quality are able to pass or not. So create. Then go to analysis, load step, enter the as test, select the type as model analysis, check the box SPC. For method structure, select EIGRL and say create. Click return to exit this panel. Save this file. Go to analysis, radius, and run option to analysis and say radius. So if this will have the free run, it is also known as free analysis, which is used to check the connectivity or the mesh quality. So if it pass with the free analysis, so we can perform any type of analysis in this roll cage structure, whether it is static, dynamic, front impact, side impact, rollover, any type of analysis we can perform. So for that we have to first, we are just checking whether these elements are having enough good quality so that it can run or simulate any type of analysis. So as the number of elements are very high, I can show you tools, count. So it will take much time. To check the number of elements, go to tools, count, and say all. So there are around 1,11,148 elements are there. And to calculate the mass, click on mass calc. Select the component for which you want to calculate the mass. So for this component, the mass is coming as 0.005, means around 58 kgs. So the roll cage structure is massed as 58 kgs. So accordingly I have to apply the loads and boundary condition on it. Or we can also input some of the dead weights to increase the weight of this roll cage structure. So now I'll check whether this is completed or not. So it will take some more time to complete the analysis as the number of elements and nodes are very high. So now as you can see, my analysis has got completed. So this meshing is completely perfect to perform any type of analysis using this 2D mesh structure. I'm not interested in viewing the results because I have not applied the constraint and on this model, so the results will not be accurate. So to solve this model, it's not my aim to have this results. I have done the analysis to check whether these elements are passing all the required quality checks and can perform the analysis on these model or these elements. So you can see on the 2D structure you can perform the mesh model. Now I'll show you one basic example that why we require 2D mesh on the mid surface itself. So first I'll go to mask. From Dropbox, select the elements and select a portion of the elements. As you can see here, I'll select this much and say mask, and then open the 2D roll cage structure and surfaces and mask and reverse and elements and reverse. Also I will mask these few more elements. So now you can see it has generated the meshing at this middle surface, and if I view this in the 3D representation, so you can see it has captured the geometry perfectly. So this is the aim of the 2D meshing, that it should capture the geometry. Once once you convert it into 2D, it should have this perfect roll cage along the thickness. It should capture the perfect geometry along the thickness. Okay, so in this way I have ended the video.